This problem explores the relationship between mechanical, potential, and kinetic energies. The mechanical energy is the total energy of the system. The law of conservation of energy states that the energy in a closed, isolated system is constant, that it can change forms but is never lost. So our ball moves throughout its flight, the kinetic and potential energies will change, transferring between each other as the velocity of the ball changes, but the mechanical energy will remain constant. Here is the data for our problem. We know the initial velocity of the ball, and we know at the maximum height the ball's velocity is 0. We are going to use this chart to help us solve the problem. Notice the units for the energies are all the same. All energy has the units joules. We will start with the potential energy of the ball at the initial height. Since the height is 0, there is no potential energy with respect to the ground. This makes our potential energy 0. Our kinetic energy at the initial height can be found because we know the ball's mass and velocity. Since the potential energy is 0, the mechanical energy is made up for the sum of both the potential and the kinetic energies. The mechanical energy is equal to the kinetic energy. Next we will find the energies at the specified height of 2.50 meters. Since there are no outside forces acting on the system adding energy, the mechanical energy will not change at any point in the system. We can find the potential energy at this point because we know the mass and the height of the ball. We don't know the velocity, so we can find the kinetic energy by using our conservation of energy relationship. The final point in the system is the maximum height of the ball. The mechanical energy does not change. Since the ball has no velocity, it cannot have kinetic energy, so this is 0. Finally, we can find the potential energy using the conservation of energy relationship. All of the energy is potential energy at the maximum height.